In this video, I want to talk about common types of chemical reactions. So types of chemical reactions. We're of course going to write chemical equations, right, to represent that chemical reaction. So types of chemical reactions. And we're going to go through 6 common types. So the first one is going to be a combination. And the nice thing is the name often tells us what's happening. So in a combination reaction, we're actually going to be combining reactants. So we could say 2 or more reactants produces a single product. So we're literally going to be combining things. The iron example that I did on the last video would be a combination. So I'm taking iron, I'm combining it with oxygen, and we're producing iron 3 oxide. We did balance this. So 6 oxygens on both sides and then 2 iron. So more than one reactant, in this case 2, producing a single product. Our second type is actually the complete opposite of a combination, and that's a decomposition. Literally the complete opposite. So this time a single reactant produces more than one product. And we could do the decomposition of water. So water liquid can decompose to form hydrogen gas plus oxygen gas. And of course this one isn't balanced. I have 2 oxygen on my product side, only 1 on my reactant, so I need a 2 there. Now my hydrogen are messed up, so I need a 2 there. So decomposition, 1 reactant, it's producing more than 1 product. We're going to look at a single replacement next. So with this one, what we have is an actual just single atom. You can have more than one of them, but it's not bonded to anything. So just copper. I could have 2 copper, but it's not copper in a compound, it's just copper. And then I have a compound. And what's going to happen is the one that's single is going to replace one of the atoms that's in that compound. So kind of just a generic version. I could say A, that's my single one, plus B, which is bonded to C. And then A is going to replace B. So B is now going to be by itself, and A is bonded to C. So single replacement. A real example for us, we could do zinc. Zinc solid will react with copper 2 sulfate, which is aqueous, and that will produce copper solid plus zinc sulfate, which is aqueous. So zinc is replacing copper, and then copper would be by itself, and zinc would be bonded to sulfate. Number 4 is a double replacement. Again, the name is really telling us what's happening. This time I'm going to have 2 compounds, and we're essentially going to swap partners. So I'm going to have a double replacement. If we look at just an A-B sort of example, I have A bonded to B, and I have C bonded to D. So 2 compounds, and then we're essentially going to swap partners. So A is going to be bonded to D, and C is going to be bonded to B. Let's look at what's a real example for us. How about sodium carbonate? Don't need the parentheses around this one. I'm just going to put them there. And we're going to react it with barium chloride. So what's going to happen is the sodium is going to combine with the chlorine, or chloride, I should say, because sodium has a +1 charge when it forms an ion, right? It's going to lose that one valence shell electron to have a filled octet. Chlorine, before it's an ion, right, has 7 valence electrons. It's going to gain 1 to become more stable, right, to get that filled octet. So it's going to have a -1 charge. So because sodium has a +1, chloride is a -1, I just need one of each when I put those together. And then barium is a +2. It's in group 2 of our periodic table. It has 2 valence electrons. It's going to lose both of those. Carbonate is one of those polyatomic ions you needed to memorize. It has a -2 charge. So since barium is +2, carbonate's -2, I only need one of each, and I've run out of room, so we'll put them there. Oop, 3, and 2 in my head. And you don't need the parentheses in either spot. The reason I'm putting them there is because this is one of those examples where I'm going to balance polyatomic ions as an entity. So instead of thinking of carbon and oxygen as separate, I'm thinking of them as together. So balancing this one, I have 2 sodium on my reactant side, only 1 on my product. So I'm going to put a 2 there. That also gives me 2 chloride ions. Barium chloride, 2 chloride ions. 1 barium on my reactant side, 1 barium on my product. 1 carbonate on my reactant, 1 carbonate on my product. So this one is balanced for us. Again, double replacement because I'm doing 2 replacements. Sodium and barium are switching partners essentially. Our fourth one is an acid-base neutralization reaction, which honestly is just a subtype of a double replacement. We could actually do double replacement and then do like subtypes under that. The one that we did above is actually a precipitation reaction. But that's just, again, a type of double replacement. So acid-base neutralization. Our book is doing it separately, so I'm going to do it separate. But I do want you to know that it is a type of double replacement. The example that I did in the last video for balancing that had water, and I thought of water as HOH, that was an acid-base neutralization reaction. So what we're doing in this one is my acid and is reacting with a base. We're producing water as one of our products, and then a salt as the other. So it's going to be, let's get the green color. It's going to be acid plus base. We're making water plus something called a salt. The salt is really just after we do the double replacement, it's the other thing that you get that's not water, if that makes any sense. I'll show you here. So we can do, let's do H2SO4, so sulfuric acid, and I'm going to react it with sodium hydroxide. So what I'm going to do is I'm going to think of this as being H and SO4. Again, it is a covalent bond. They're not separate. They do have charges. I'm just leaving it off for now. We can come back and talk about those after. Let's actually put them, that's a plus charge. Sulfate has a -2. We are going to need them when we write our products. Sodium and then hydroxide. So, you know how I said it's a type of double replacement? What I'm going to do is I'm going to take this hydrogen and I'm going to combine it with oxygen. We're going to combine it, with OH. So we're going to swap partners. And that's going to give me my water molecule, right? If I want to think about it for balancing purposes, again, of HOH. Again, it's not, right? There's a covalent bond between that oxygen and both hydrogen. But for balancing purposes, I'm going to think of it that way. And then you can kind of see that it's a type of double replacement. And then I'm going to combine the sodium with the sulfate, because sodium has a +1 charge when it's an ion and sulfate has a -2 charge. I'm going to need 2 sodium. Remember, our net charge has to be equal to 0 for ionic compounds, right? Total number of electrons lost must equal total number of electrons gained. So then for balancing, I'm going to keep sulfate together. I'm going to keep hydroxide together. Again, remembering that water, just for balancing purposes, I'm going to think of this way. It's covalent again, but it's going to help me balance it. It's just a shortcut. So if I look at sodium hydroxide, I have 1 sodium. If I look at sodium sulfate on my reactant side, I have 2. So I'm going to start by putting a 2 here. That's going to give me 2 hydroxide. So if I put a 2 in front of water, I'm getting 2 OHs. That also gives me 2 hydrogen. If I go back over to my reactant side, sulfuric acid, 2 hydrogen, 1 sulfate, 1 sulfate. So I just need the 2 in front of sodium hydroxide and then that 2 in front of water. Don't forget to go back up and stick it there. This is only my work. One more for us, and that's a combustion reaction. And I also mentioned those in the last video when we were balancing. So combustion. So for combustion, what we're going to have is some sort of fuel. And for us, it's going to contain carbon, hydrogen, and then possibly, not always, oxygen. It can be other things, but we're going to stick to this, particularly since we have a condensed semester now. So plus some sort of oxidizer. And for us, this is going to be oxygen. So we're going to have some sort of compound that has carbon and hydrogen in it, maybe oxygen also. I'm going to react it with oxygen, and then we're going to produce carbon dioxide plus water. There are other types, like you could have sulfur and you get sulfur dioxide instead of carbon dioxide if your fuel has sulfur in it. We're not going to look at any of those. Just know that there are other possibilities. All the ones I give you, though, will take this form this semester. So we'll just do a simple, so CH4 plus oxygen going to carbon dioxide plus water. And then remember, I want to balance my carbons first. Right now they are balanced. I'm going to do my hydrogen next. So CH4 is 4 hydrogen, water just has 2. So a 2 goes in front of water. That gives me 4 hydrogen. On my product side now, I have 2 oxygen with CO2. I have 2 oxygen with water. So I have 4 oxygen total on that side. So I'm going to go back to my reactant side, put a 2 in front of O2, that's going to give me my 4 oxygen. So for these guys, it's just basically if I give you an equation, be able to balance it, and then right now be able to tell me what type it is. We will actually, in the next few videos, get into predicting products for all of them except for combination and decomposition. In combination, combustion, we've already done that. This is always my products. You're never going to get anything else. But we're going to look at more detail, particularly on the double replacement and the acid-base neutralization reaction.